as you know, as some of you had me as your professor, I taught research methodology for like 15, 20 years. I actually invented that class many years ago. And I did not invent it because I learned from a very famous professor, Bruno Buchberger. He was a very famous professor. He invented Grabner spaces or something. And I was talking to him, and he was pointing out to me that how hard it is to write a paper and how to do research. By the way, I hope that the voice is okay. It's okay. And so I decided to do this experiment. So actually writing a paper and how to do research is actually quite much more complicated than people think. Actually, one of the typical mistakes that people make when they do a PhD, they think that doing a PhD is all about taking classes and giving exams or whatever. No, doing a PhD is about how to learn how to think, how to interact with the others, and how to do research. So my idea has been to teach this class for the group, because after stopping teaching this class, I've been telling you the same stuff over and over again. And I really think that it's very important the first year of a PhD student to really get some classes on this. Of course, there is a course on research methodology already taught by a very good professor. So this is complementary to that. And I think we'll also teach complementary stuff. So ultimately, the goal of this class is going to be really to teach you how to do research and to write a paper, how to make presentations, which are actually the key parts in a PhD. How am I going to organize it? First of all, this lecture is registered, which means we are creating a web page with this lecture and all my lectures. And my idea is that next year I will not teach this lecture again, but I'll ask the students to look at the lectures. But my lectures are only part of the work, because some of you, or most of you, you will have to do your homework as well. So this series of lectures will be a split between what I do and what you do. And also in the next following years, your lectures and the lecture of the students, if they want, will be published on the website as well. Of course, you're not professors, so if you don't want, we don't put you on the website. But I do hope that you will do it, because it's going to be good for your students and for your colleague students next years. So what is going to be, as I said, in this class is going to be my own presentation and teaching. What is going to be your contribution? Oh, it's very simple. As becoming old, I learned that the best way to check what you don't know is just by trying to do it. There's nothing more better than reality check. So I teach you how to define what the problem is, and you'll have to make a presentation, think what the problem is. I'll teach you how to write a paper, and you'll have to write a paper. I'll teach you how to do a presentation, and you will have to make a presentation. Okay? So the idea here is that for each of the tasks, on some of you, for sure the volunteers, and also some almost volunteers, which I'll volunteer them, you will have to do all of this, okay, for your own interest. So there will be like four types of interventions on your side. Intervention number one, some of you, you'll have to make a presentation on the general problem. What is the problem? I'll get back to this to you. And this will be the first series of lectures. Some of you will have to discuss after they've written the paper, their own paper. It's going to be contribution number two. And some of you will have to give a contribution in giving a presentation. These are three of them. But the fourth one is that when you give a presentation, when you write a paper, your colleagues will have to evaluate you. So when you write a paper, you write a paper with me. I mean, driving, giving you feedback outside the lectures. So I'm committing not only to give these lectures, but spending time talking to you, giving you feedback. And then you write a paper, and the paper will be reviewed by some of you, right? And when you present the paper, those reviewing will have to do their best to shoot you down. You know what shooting you down means? It's very simple. When you do in research is a very fair game, which is a game where you have to show that you know how to think. Research is all about thinking. So it's just a game. It's also a very nice game. Very clean, I would say, in most cases. So the point will be that you give the paper to the people, you give the presentation, and all of us, but in particular 3 or 4 of us, the ones not presenting, will have to do their best to show that your argument is wrong. The one who loses pays the pizza. Okay? So this is going to be the game. It's very fundamental. This means that you have to learn how to review the paper by others. You have to learn how to ask questions. And you have to learn how to engage in discussion, right? And my idea is that we can do this in public, because you only learn by making mistakes, as I learned. So, and we analyze this together, and this will be part of the game. And also in particular, because why this is easier somehow with European Western students, like Asian students are more reluctant to doing this. So I hope that we'll overcome this limitation, and they will just find out that it's actually easier than they think. As I usually say, asking questions, getting in discussion is hard the first time. After the second time, it's a little easier. At the third time is normal. But if you don't do it at least 3 times, you never learn, okay? So as I said, I'm going to start the introductory part. I'm going to just describe a little bit more how organize the lecture. I'm already doing it. And we will do these lectures in time. But there will be 3 types of lecture on your side. Lecture number 1, what is a problem, what is a solution? There's a general issue of what is a PhD, what it means to do research. Second type of lectures on how to write a paper, discussing the paper, bugs in the paper, bugs in the style writing the paper. The third one will be making a presentation. For all of them, you'll have we together with Xiaoye, we are already organizing it. You have to volunteer for all of this. For sure, I'm doing like this. For the first problem, which is how to do research, for sure the non-optional volunteers are the first year PhD students, which is like Ivan, Erdene, and Hadi will have to present their general view on their own research. And we will, I will select together with Xiaoye, people asking questions to them, trying to shoot them down. And we do a mix of people, senior people in that area, and junior people need just to practice, okay? The second one is going to be how to write a paper. How to write paper is going to be a real paper, which is, and this to me is going to be with all of you, even the senior people, if you want to do it. We just set up a real paper, not a fake paper. It's not a qualified paper, a real paper. So we decide that we have some hope by that deadline to submit a paper, and we write the paper. You write the paper, and I supervise you, and then you come and present it, and people read it. And we go exactly at the same as you did before. You submit the title, discussing with me, of course, so that we help. All of this discussing with me is part of the process of learning, right? Having someone advisor is exactly an advisor is useful. You have to, I mean, doing research is not easy. You have to really try to do it, and this is exactly why an advisor can be useful, okay? So we got the title, you submit the title to Xiaoye, and then we will find that the 3 or 4 reviewers, we have to see how to balance. One point is not that we just do all the papers now, we will just take the time. I see this as an ongoing process. Maybe suppose that there is a deadline in November, we just do in November. This means maybe we do 2 presentations in between. Some have the deadline in April, we do it in April, okay? Actually, the more it's diluted, it's better, because otherwise, if I have 20 people, I don't do it, right? This will be part of the discussion. Okay, and for the presentation is kind of easier, because the presentation, of course, you have the usual argument of the qualifying presentations, but they can be done more asynchronously. But clearly, you cannot do a presentation if first you have not written a paper, if you've not really thought hard enough of the topic. Of course, as you see in my presentations, it's not that you can also give presentation. There are many reasons why you want to give a presentation. You want to give a presentation because you want feedback, early days of the PhD or the work. Like you want to just do brainstorming. You want to give a vision talk, or you're halfway in the analysis, you want to just present the results, collect feedback, or is at the end you have the results, you want to sell the message and maybe get published and become visible. Okay. So we have mainly in the presentation, we have much more flexibility, and therefore with this we can plan for it. With Xiaoye, we'll have to plan for this and put dates. With the presentation, I think we are more flexible. Let me just say that I want to make this an ongoing process. Again, you understand? We start now and we end when I retired, and then someone else will take my position, and they can plan for this, right? So which is this is going to be part of the game. And then, of course, this is going to be part of the seminar series, okay? And of course, as usual, they're going to be even for the presentation, some people prepare for it, right? You see, the issue of being engaged in learning, how to engage in discussion is fundamental. It's actually the most important thing in science and research. People don't understand, but if you have the most brilliant idea, if you don't convince the other people, then it's useless. Maybe it's good for you, but it's useless for society. Okay? So I'm giving the next lecture in 1 week, I guess, right? Or 2 weeks, I don't remember. But the idea will be that with Xiaoye, in the next 1 or 2 days, we prepare an Excel sheet, and you have to voluntarily sign up for all of them or most of them. As I said, for the presentations, on the first type of presentations, are fundamental for the youngsters, but anybody can sign if you want to do it. I don't know, it's really open. This is an opportunity. It's something for you to learn, okay? Then for the papers and the presentation, I would expect most of you, all of you, to do it. And I think really for the paper in particular, the most critical ones, because that one we do for real, okay? And the presentation we do for real when you have to do a presentation. If they accept a paper, the paper accepted, then we become for real, okay? We'll do it for a year, and we will hire someone to shoot you down, okay? Okay, remember that people think that people think that people cite papers. No, people cite people. So is the top people cite people, which is the only way you have to your work to be valued. You have to go to the top places, survive, show them that you know what you're doing, and then they will talk to you. You understand? So this issue of scientific discussion is fundamental. Okay. So this is the general setting, the organizational setting. I want to talk 2 more things. As I said, I still have, like I said, I want to talk for half an hour, a little bit more. As I said, all this material approved by you will be published online. And with Xiaoye, we already started a web page. We will start a research methodology web page where we just put all the presentation. As I said, my presentation are going to go online. Yours, if you want, as a service to your fellow students, right? So what I'm going to talk about, my presentations. My presentation is going to be about 4 areas. And the first year is going to be how to do a PhD. 1 hour. There are some things, to do a PhD to me is really a general topic for the general topic of a general title for the general topic, to understand what doing research is all about. As I said, the common mistake that people do, in particular when they're younger, when they come to the PhD, they think that PhD is just like a master thesis, more or less, just a little longer. No, that's nothing to do with it. As my usual definition that I will repeat later, a PhD is all about solving a problem by yourself. And the problem, which is difficult enough, it takes 3 years to solve, at least. Because as I say later, 3 years is not good enough for a PhD, it's too short. So the first lecture, 1 hour after this lecture, is going to be how to do a PhD. Then the next one is going to be like 2.5 hours, how to write a paper. And here is going to be a lot of general guidelines. But then the idea would be that I give the guidelines, and then as in the case of before of how to do the PhD, you make presentations of these topics, and we work out the details, right? I expect that at the beginning I'll be the one complaining more to give you the feeling how to do it, but then I expect then all of you should become valuable in this. Then there is a very, I don't know if you know about this. There is a very famous cartoon, PhD comics. Have you ever seen PhD comics? It's a very nice cartoon about doing a PhD. It's very nice. And there was one cartoon which said, "What did you learn in PhD?" And he said, "I learned to do PowerPoint slides," right? Which actually is very much the case. Why? Because, I mean, to write PhD slides, as you found out, some of you, to write slides and being able to synthesize in a presentation, be able to be understood is very, very complex. And slides and making presentations, which is the last lecture that I'm going to present, is actually easier than writing a paper. Because in the presentation, first of all, as I say, words disappear. So if there's something wrong, you can always claim that you don't remember, you made a mistake. But when you write something, it's going to be in their hands. Number 2 is interactive. And it's shorter somehow. The topic is much smaller. So this is going to be the third topic, but we do how to do a presentation after writing a paper, because I want the presentation to be done on writing the paper. And of course, when you do a presentation, all the usual arguments for how to write a paper apply, only simpler. Plus, you have another issue, which is how you actually convince people to listen to you, right? There is a important point. We all think when you start a master's or a PhD that we do research, everybody cares about what you do. No, people don't care. In particular, the ones which are more aggressive, positively aggressive, competitive, they want to do better than you. And they are not ready to listen to you unless it's mandatory for them to survive themselves, right? So not that you come here and that's an easy game. No, it's a very hard game. The good thing is, I said that I think the research community is kind of honest. I mean, as I see in my next lecture, I'll tell you more. There are very good rules important rules about honesty and fairness. But within fairness, within honesty, people have the right, and they will do so, to try to shoot you down, to show that you're wrong as much as possible, right? Your paper accepted is their rejection if you do the same topic. Even if you get both accepted, the one with more arguments is going to be the one being more cited, right? So it's a very nice competition to do. Also because you learn a lot, but it's not easy, okay? So as I said, these are the 4 lectures, and there is some set of tentative dates, like today is the 9th of February. There is how to do a PhD the 23rd of February, how to write a paper the 2nd of March, and how to do a presentation the 9th of March. But I would consider this flexible, okay? The saying that will adjust also because I think it will be important that I will give this class a top priority. and we will adjust the which is I can delay my presentation. There's something in between. For sure, in one of these lectures, as I said, like no more than 2 weeks from now, or maybe 3 weeks, or up to 4 weeks, I want the first presentation by Adi, Erdene, and Ivan. I hope that Ivan is online, and so that you know that you have homework to do. Okay, now, and what are they going to talk about? And by at least those three. But for instance, if Samuel or someone else wants to do a presentation, if Matteo wants to give a presentation, it doesn't matter. Remember that it is all in your interest. It's going to be work, but those of you who do it, so don't feel it's going to be good for you. So don't feel ashamed you do it. It's going to be a very nice game to play and to learn how to play. Okay, so this is for the course, and I want you to register because this is going to set the stage for all the slides, also for the future. I now want to do one more thing. You now need to share the screen. Okay, I share my screen. Okay, so first of all these slides are in this How to Do Research, which is a folder under No Dive Google Drive Resources Training. All these slides are there. They were already there, but now I edited them. I deleted some material. And these slides, the registration, so these slides will be put online. Xiaolei and Xiaoye, you manage this, but they're going to be there, and they're going to be internal, okay? And by we create also the web page. As you see, there is a bunch of topics. What is science about? How to do a PhD? How to write a paper? How to prepare a qualifying? How to do a review? How to read? How to do a presentation? There is more material that I'm going to present. I decided not to give a talk on how to do a review. I thought first we see how you go, but the material is online. Then if you see it goes bad, I may just do like half an hour presenter to do a review. Okay. Remember that the review is a written review for a paper and an oral review for asking questions, right? Remember that in science, the interaction part is fundamental. Let me repeat. You can be Einstein, but if you don't convince the other that you're Einstein, what you do is irrelevant for humanity and for science. It's good for you, but not for humanity. Okay, good. So all of the material is here. And then what I wanted to say, what I want to do, I want to start out to do a PhD. Okay, here we are. So this is kind of the preliminary to everything. And what I think I told you like 1 million times. And as I was telling Matteo like 2 weeks ago, or I don't remember when, it's interesting because it's so simple that you think you understand, but then as you will do later, when you try to do it, 100% you'll fail to do it. It's like when I tell you how to write a paper, you say, oh, it's obvious, then you write a paper and you just get it wrong, just because it is simple. So I'm registering this because I really wanted to say this and concentrate, because this is really the core of research. Because the way it works is that I'm going to say this, and maybe you go there, you look at this slide 100 times, and you not understand this slide. And then 101 time, you go there, you read the slide, you say, oh, now I see. At that point, everything will be simple and obvious. But this is kind of, but this is not easy to get to this. And therefore, I'm just using this to really tell you something. Being pessimistic, I'm sorry to be so arrogant about the probability that you understand what I'm telling you. I think most of you will not understand, but I do have some hope that in due time you'll understand if you're really interested in learning, okay? So, research is very simple. There are problems to solve and solutions to give for the problems. Okay, so let me just give that when I was teaching this class, I gave homework to all my students, and they say, okay, next time you come and send me an email with a 3-line description of your problem. All of them would describe me solutions. None of them would know what the problem is. Okay, also because in science, teaching about solutions is much easier because the solution is about learning, okay, I build a neural network, so it's just learn how to do it. But problem is much harder. What makes a problem a problem? It's much harder. So, problem statement, the what? The problem statement is about what we cannot do today, right? And then you can say, oh, well, I mean, I cannot ride a bike. Is that the problem? No, because when we say what I cannot do today, I mean worldwide. This must be something that cannot be done. When you do the PhD presentation, if someone says, this has already been done, then you do not get the PhD, okay? So, the issue is exactly this. What is the problem? Namely, what is something that people don't know how to do, right? There are many types of problems. For instance, now, like explainability in deep neural network is a problem. Do we know how to do it? No. How big a problem is? Oh, well, it's so big that it's not even a problem because it's actually so vague, right? So a problem, to be a problem, must be able to have a solution. We don't know what the solution is yet, right? But if you tell me, I don't know how to go to Mars, that's not a problem, it's too vague. There are like 2 billion problems to solve it. So when, in particular, the qualifying people, you have to say what is a problem, and the ones who've done it, has to be concrete enough. Has to be concrete enough. Then when you show the solution, you can prove the solution. What makes a solution a solution? How do you know the solution is a solution? First of all, you must have a problem for which you can have a solution. So if the problem is too vague, typical example in qualifying, you get qualifying, like the admission to the second year to the PhD, then you get these problems which are vague, right? So vague, I want to go to Mars. Is that a problem? Yes. If you go to the bar, to the pub, you drink a beer, it is a problem. Yes, we know how to go to Mars. Well, but in practice, it's not your problem. You have no hope. Right? Are you talking about what? The Starship? How to buy the gas? How to learn how to drive a car? I don't know. Okay. So this is the first problem. But as I said, this problem has to be a problem for everybody. How do you know this? It requires full knowledge of the state of the art. Full knowledge. What does full knowledge? Like there are like 10 million papers per year. How do you know it's relevant knowledge, right? You have to learn how to do the state of the art. As you know, for all of those, the way we work in our group, the way you do it is that when you come in, usually give you some kind of dirty work. Because when I was young, it was like 10 years ago, with the new PhD would come and would tell them to read a lot of papers. And then in the end, would come to do something concrete. But what turned out to be is that people read a lot of papers, they have a lot of theory, no concrete understanding. So now my standard approach is vice versa. I give you some dirty work to do, like writing code, something very concrete. And then after that, after you got your hands dirty, after you read the code, after you become concrete, you lift up and do the state of the art. But at that time, having read the code, whatever, gives you what I call the mental model. And now that time is the time to do the state of the art. So the state of the art is fundamental because, in particular, when you do the qualifying at the beginning, always, if you write a paper, the first thing that you write in the paper, as you see in the paper, is the problem you're trying to solve. But you just cannot say this is a problem. You have to show that the problem is a problem. How do you solve it? We see that when you write a paper by saying, look here, these papers are published. These papers are published. They say they can do this, but those papers, I understand that they only do that far. They only go that far. In those papers, they even say explicitly, we don't know how to do this. So what they say that they cannot do, or what you can argue they say they cannot do, can become your problem, right? So those of you will have to give a presentation on this, which means at least Hadi RDNA, and even you'll have to work out your problem, your relevant state of the art. Notice that as I did with all of you, your first state of the art is going to be like 1,000 papers. Why? Because at the beginning, it's such you go to Google Scholar, you go to Google whatever, and you just look for them. You just get the general idea, the general area. The state of the art later on becomes much more concrete, because when you publish a paper, you can't say, you have to be very specific, because ultimately when you go to the solution to the paper, you become very concrete. But in this initial phase, but in all at different levels of details, in all the phases of your research, always your work is all about identifying the problem. And let me say that identifying the problem, as I usually say, is much harder than finding the solution. I'll get back to this in one of my slides. So the problem is something you cannot do. Let me go to the impact, the why question. Once I had a student, or I was in a PhD committee evaluating a student, and I asked, why did you do this? And I think it was he, I don't remember. He said me because my supervisor told me, right? That's just what you don't want to say, right? Right. The why question is fundamental. Remember that ultimately, the why question is what makes the impact. The why question, how big is your why question, is the importance of your work. I mean, you can become wonderful in writing a lot of code, a lot of technology, but the impact, the why question, is the most important one. The why means, in which way, by doing this, in the general term, humanity has progressed. If I do this tomorrow, what can we do more? Why what we can do is going to be improve the quality of humanity, and this is why some people don't want to do research on arms and whatever. So let me give a concrete example. Do we know to build a car with 11 wheels? My usual example. Usually I say 5 wheels. Do we know to build a car with 11 wheels? Is anybody knowing how to build a car with 11 wheels? No. Is that the problem? No. Why is that the problem? Because we don't need it. Even if we build a car with 11 wheels, is there a specific problem we need to solve? No. Like deep neural networks, they are explainable. No. Is that the problem? Yes. In the web, no. Because in the web, because they may be, why? Yes, it is a problem. Why? It is a problem because we don't know how they behave. In all the AI, even in the early days when I was young, all the AIs have the problem that they don't know when they make mistakes. There's a property of negative property of AI is called brittleness. They are brittle, they are superficial. Okay, so you say in general, explainability is a problem. Well, but then the question is, if explainability is a problem, why did they have so successful? They are so successful. So no neural network is explainable, we argue. And the more successful, the bigger it is, the less explainable. So why are we using them? Since they are not so explainable. You see? Answers? They work well, but they are not explainable. Eh? It's not a problem. I said it is a problem. So is it a problem or no? Wait, if they are using that, it's not a problem. Correctly so. But correctly so, we are using deep neural network, and they have been so successful because their explainability is not a problem. But now everybody knows that explainability in neural networks is a problem. So what is the answer?
Only in certain others that.
Okay, so that's a good answer. So the issue is explainability is that a problem, right? Well, suppose that you use the neural network for the web, right, or for improving Google search. Suppose that you don't know why the neural net works, and it makes a mistake. Is that the problem? Not really. Actually, it is a problem these days, but in those days was not a problem. Why? Because the cost of a mistake is very low. Not only that, in Google, if you don't have Google, you have no answer. And as I usually say, some answer is better than no answer. So, but why now neural networks have become, the issue of explainability has become so important? Because people thought, oh, wow, China started, they said, we want to do AI, we want to do the next generation systems in AI. So we want to apply neural network to medicine. We want to apply neural network to services, to like, and therefore, and then since as usual, China started and the US went and now Europe go, and everybody go because in variety so, because the one who makes the new leap in technology is gonna, as the United States have done in the last 20 years, we're gonna take the lead technologically. But now here we are, and now you are using neural networks in medicine. Now here do you see any doctor, I mean, signing a form where he gives a medicine based on the decision made by a machine that he has no idea what it is, he has no idea the data which he was training on, he has no idea what it runs, and ultimately that person can die. And by the way, the person can die, he can even say, I don't care about this person, but if science, he goes to jail. So why is it a problem? Because it is a problem because, you see, even because, yes?
For example, additional machine learning models, the positives are so fast, negatives also is other kinds of mistakes. Also, secondly, making mistakes in terms of in the interface environment and finding what kind of mistake someone, their costs are very different. So the explainability is very important in terms of the industry.
In that one,
yeah. In terms of say the other decision making where the losses are insignificant, then it's not that important.
We agree. Marcelo?
Just in the terminology, I think we are abstracting too much in the sense that if we are using something, this means this is a solution. We don't use problems. So if we say that explainability is used, this means that the solution that we build over it, we are using it. So we are describing the solution part, but this is an abstraction for us. We understand that explainability within that solution, there are problems behind. And we want to talk about this, but the problem actually is that the results that these solutions are giving are not explained enough.
Exactly. So there is an issue of what explainability is. By the way, let me make a point, which is, do you suppose, and there are levels of explainability, right? Yeah. Suppose that now we have, and by myself here, there are groups, team and myself, we work on some level of explainability, right? So we do explainability in the neural network, right? And we, as computer science developers, because there is researchers, not even developers, we produce a good explainability. And then we say, oh yes, this is great, it works. Now we give, and now these are first explainability for us, computer scientists, which says that we train with them. Now we give the software to a pathologist, to a medical doctor. You think that our explanation is going to be good for him? Of course not. He doesn't even know what we're talking about, right? And this is why I'm very skeptical these days with the current work in deep learning, not because I think deep learning is wrong. Deep learning was a major improvement, but I'm saying that the issue of explainability is the core issue. And of course, different research areas will have different levels of explainability. And we are very far from that. And by the way, personally, I don't think there is any hope to do explainability using the technology people are doing. But the last one is my own opinion. This is why I do research in a certain way. I may be wrong, we'll see. Who wins, wins and gets the new wave. It's very simple. And it's perfectly fine for me to be pessimistic and the other to be optimistic. But if you are both smart, we'll learn, because you see, people think in research, people think at the impact level, the problem level, the solution level, people who think different from you are good if you play right, because they ask you the right questions. Writing a paper, getting a review, giving a talk is fundamental in the measure in which it allows you to get feedback. Okay, so opposite opinions is right, not good, and because ultimately the winner gets a paper accepted, and most likely in many cases there's space for everybody, right? So this is the second component. So I said the impact, and usually when I tell you later, I'll tell you later that in the paper there's a first thing called the context. The first paragraph in the paper, what they call the context, is the why question. Usually, in particular, the why question to be answered is very complicated. It takes a lot of experience, years. And also, unless you write a manifesto paper, a vision paper, manifesto papers are those papers where you say where you're going to go in the next 10 years. The manifesto paper is all about what you're going to do the 10 years. They are white paper questions. They are white papers, question papers. But in normal papers, this plays not so much a role, but it is important enough to have a paragraph. And by the way, when you write that one paragraph, you basically set up the entire scenario. By that paragraph, you define the target audience. We see later why the target audience is fundamental. The why question for a computer scientist is different from the why question for the medical doctor, which is different from the why question for an engineer in hardware and so on. Okay? So the why question, by the way, the why question is very important in qualifying. And the why question is important to start at the beginning, but in general, people tend to forget too soon the why question, and therefore tend to do, what does happen if you forget the why question? This means that since you don't think about it, you're gonna build work which is driven by the solution space or by the problems, which most likely means is low impact. This is what they call the incremental work. If you look now deep learning, 99.99% of the deep learning today is incremental work. By the way, incremental work can be arbitrarily hard, can complicated stuff. But we'll have to see how much of this work is going to have an impact. And by the way, this is happening with deep learning because these are the current trend. But if you look 10 years ago, when we were doing KR, we were doing a lot of logic, we were the same. There was very good motivations, and then we ended up doing a lot of theorems. I became professor with a lot of theorems, and now they're useless. When people say, yes, you do, someone argue, the mathematicians, you do research, then someone will use it. Well, I mean, okay, this is a good argument. I'm fine with it. I'm not like that. And I do think that in engineering, because computer science is engineering, it's about building things. It's a very hard, it's a very special type of engineering because we don't build bridges, we don't build cars, we build minds, artificial minds. So but we build minds, we build information processing tools. I think the why question is important. So the point of all of this is that, in particular, and then Hadi. So in your presentation, Hadi, RDNA, whatever is going to do, you have to spend a lot of time in the what and so in the why. And the why you find out is going to be the hardest. Hadi.
Which one is the probability? The solution itself or the impact?
What is one? The
solution itself. The solution.
No, the question. What?
Which one has highest probability? Higher probability.
High probability of what?
For the impact, society or.
No, this is there is no recipe. You have to think. You have to decide yourself. This is exactly why PhD is all about. Because you see, research is simple, but one fundamental issue in research, people don't. What about when you do research? You're doing something that nobody has done before. So the bottom line is that you have no clue, right? So you look at the problem, you decide. And of course, this is why the advice is so important at the beginning, because you have to have a lot of experience.
So based on?
Depends on, but you have to read the state of the art. You have to also what the problem is. Also depends on your taste, which is in the initial phase when you have to choose the advisor and trust him. Otherwise, whatever. And then pretty much I'm advisor, I can be as open as I want by me, right? So I'm teaching my own way. And at the beginning, pretty much I will induce a problem. I'll help a lot you into the problem, into the impact, and also the solution. But the impact and problem are definitely to me as an advisor. Now, the point is that the more you move on in the experience, the more you learn by yourself, the more you develop your taste. Some people, including me, argue that taste is the most important part of research. It would be wrong to keep doing, you have to give your own interpretation of what research is all about. You have to do what you think is most interesting, most fun for you. This is actually, but as a side effect, by doing this, you maximize the probability of doing something useful. Because if you do someone told you, well, you're just not in a good mood, and why should you do it right? But there is an initial phase. And in the initial phase, you have no clue. And sometimes in your case, you start why? For some coincidence. But there is something that I learned. It really, in research, it does not really matter what you do research on. No matter what you do research on, the process is the same, the difficulties are the same, and ultimately it's going to be your own taste, your own capability. And sometimes can come in finding a good impact, a good motivating example, a very nice, compelling, motivating example. I was discussing a very nice motivating example yesterday with Shen and Stefano. Very nice. And so just write half a page of motivating example, the why question becomes very clear, okay. Another one could be the problem statement. The problem statement, you just have to argue that if you do this, you improve the efficiency of 50%, you win. The solution statement, you do a new algorithm, again, but then you have to have how you evaluate solution, I'm gonna get in a second. So this is gonna be part of the game. So the key point here is that, and this is exactly what makes a research PhD very hard. It's not like when you do a master that you take a class, you give the exam. You see, when you take a class in the master, they already tell you what you need to know and what you need to do. You just have to repeat and be smart. In the PhD, it's like that. You, like me, were in the middle of nowhere, right? And by the way, why I'm teaching research methodology, I was teaching this when I was doing these classes. Sometimes I say this, I think I told you. Why we do research methodology? So why in research methodology is so important? Why so important? Because you see, suppose that you teach mathematics like calculus, right? It's easy to know whether you're right or wrong. It's just there is an entire books. You go to the books and you check the books and you check, right or wrong. You know to resolve differential equations, second order equation, you know, right or wrong is determined. But the question now becomes, if you do research means you're doing something that nobody has done before. How do you know? How do you know that you're right or wrong? Since you're the first time, you are the person who does this for the first time, and since you're the first time you do it, nobody else in the world has done it, and I think we get to claim this a different level of details, but that's a correct statement. Since it is the first time you do this, how do you know that what you're doing is right? Suggestions?
Way, so you follow the correct process.
You follow the process.
That's the only
so you see, in research, the solution is the process. This is why replicability is so important. It's not that what you do is right a priori. You say something, you produce a result, you say this can be done. Other people replicate it 1,000 times, and they say, okay, yes, actually it works. He says it does this, actually does the same thing. And that's the first step. Then that's when you publish the paper. Then when you do research, you say, okay, you've done the research. What you're doing is replicable. So not cheating. This doesn't work only for you, because in Trento, you can argue that with a car you go in any place in Trento, while in Chicago, maybe in a bigger city, in Beijing, which is bigger, it's not so easy, right? You understand? Replicability. But then there's the first part, which is the easy part. There's research. Then the second part is innovation. What does innovation mean? Okay, now I know how to go to the moon. Should I do it? Right, I have now 100 different ways to go to the moon. Different, competing. Which one do I choose? That's the why question. How do I do it? Right? So it's not that there is a ground truth somewhere which is in somewhere. Research actually build the truth, and you build society ultimately. And so this is why the research methodology is all about understanding the problem. And first of all, you need to know this is the problem. So you need to make sure that nobody knows how to solve it. Otherwise, you don't get a PhD. Then when you start the research, you must convince yourself, your advisor, and then your listener that what you're doing is worthwhile, and your qualifying committee. And then you have to build the solution. And now we get to the solution. So far, before getting to the solution, and then we get into the last part of this talk today, we said there is impact, there is a why question, and the problem what they don't know what to do. And we said that problem statement and state of the art go together. Remember, for any topic, you're gonna find like 1,000 papers. You have to choose the top 10 papers which show the argument. Even this is a job, as you find out when you write the papers. But now we go to the solution, right? So we said that you know that the problem is a problem because in the state of the art, you can argue based on the state of the art, nobody knows how to do it. You know that you know much less confident that the problem is a worthwhile problem because you have an infinite argument. Now you go to the solution part. Now you come to the easy part. All right. After all, when you do a master's and PhD, it's just all about solutions. So learn how to do conceptual modeling, you know how to do machine learning, you know how to do architecture, so on and so forth. Okay. So you start doing it. Okay. So now the fundamental question here is, how do you know that the solution is a solution? How do you know that the solution solves the problem? How do you convince third parties what you did solve the problem? You understand the question? So, Samuele, how do you do it?
I would say try out the solution, resolve the problem.
It's tautological. It's a tautological. So it's a solution if you resolve the problem. It's a tautology. It's a famous circular definition. No, it's not an answer.
So I would add the others say that there is a solution. And
so your research methodology is that first you convince yourself and then you try to convince the others. No,
Yeah.
it doesn't. It fails replicability. Adi, no, it's not like this.
Maybe by making a comparison.
You say you do a comparison without related approaches. How do you know they are solving your problem? So how simple research is?
Maybe they should, for example, add in their research a kind of evaluation or validation.
Evaluation and validation. What is evaluation?
Evaluation for the role.
Evaluation of what? Exactly. But what you evaluate? Okay, good. Correct. We made progress. I mean, a solution is a solution if it satisfies the evaluation.
Yeah.
Right. What is an evaluation?
when you define the problem, find the measures of.
Okay, I told you before that the problem going to the moon for us, maybe for the United States or the China government or the Europeans, especially it's a problem. But for us, not a problem, it's too big. Maybe the point when you state the problem, for the problem to be a problem, you must, together with the problem, define the problem quantitatively enough, algorithmically enough, so that implicit in the problem statement is the measures by which you evaluate. So for instance, you want a better machine learning algorithm, it's accuracy. You want to increase. This is exactly why people use the same data sets. Why? This is exactly why in the end it doesn't work. But in the short term, using the same data set is easy because I can replicate and I can improve measures. Like an operating system is going to be like execution time. Okay. Okay, so in the same way as the problem goes with the problem statement goes with the state of the art, the solution goes with the evaluation. Okay. And the way we do the evaluation is that you must be able to write in the paper, say, you see what I wrote in session number 1 or 2, that was my problem. This is my way of evaluating the evaluation. So you can call it research questions, you can call like metrics. There are many ways of doing it, but you need to have a quantitative and replicative and replicable way to measure it, okay? Okay, how do we measure? How many different ways do we have to measure? Like in deep learning, how do we measure? Right, so in deep learning, we have the benchmarking data sets, and then you have some metrics, right? That's one side, it's a quantitative way of measuring. Of course, right now, in the last 2 years, a lot of people came out, because what happens is exactly as it was happening in KR 10 years ago. What you do? Of course, we just, by the way, this exactly shows how smart is Google. It just gives us the data sets, so all the work works for them for free, for Google. So Google gets for free a lot of technology from us. But at the same time, we get papers, we don't care, we make them happy, but we go to career, that's okay. But what is the point? And then people start building. Where's the boundary? At the beginning, it's okay, but the more you move on, the more you embed in the algorithm knowledge of the data sets, right? And then you actually fail the why question. You have a solution, it's a perfectly defined solution for the perfectly defined problem, but your work is largely useless. This is the incremental work, actually. So, but anyhow, one way is quantitative. You have a quantitative way to measure, okay? But when you do theory, like you prove theorems, like mathematicians, what is the evaluation? You understand the question? Or we only do accuracy. We now have to do accuracy for our life. If you do theory, if you do theorems, why do you evaluate? How did Gödel show that he was right? Because he proved the incompleteness theorem. What is the evaluation in the theory? Is that you prove a theorem, and then you say, look at this theorem, how beautiful it is. I actually found out that in mathematics is incomplete. It cannot prove this. So the theorem you prove, the fundamental theorem used at the end, one way of calling it, is the theorem. So the evaluation is that you build the proper set of axioms so that you get to the theorems. You understand that in mathematics, all the game of writing axioms is to get the theorem you want. It's exactly cheating, like in deep learning. It's not actually cheating, it's actually part of life. You decide what is reality, you assume your own reality, and then you prove the conclusions. Okay? So that's another way. But then if you do some Haunan or Chauvier work they're doing, now we build a system. We build a system, right? We build a system where we argue that it does something. We do a lot of modeling, we build situational context, blah, blah, blah. We build a new model. How do we argue? How do we evaluate that? Because it's not that evaluation is an option. Evaluation is not an option. Evaluation, if you look at the research methodology, scientific method is there. So always have an evaluation. And when you write a paper, when you do research, you always have to keep in mind that you have a metrics for the measuring. Because if you don't have not clear, you can come with random problems for which there's going to be no way to measure. Maybe you have done a wonderful thing, but if no way to measure, that is not a result. So I evaluate in your work, Xiaoye, or Haunan, or Matteo, or even Simone. Why do we evaluate when we build systems? Yeah, find the baseline. Okay, give me an example. Because the baseline sounds very much like deep learning to me.
Just like to find the questions to users randomly or in the same time interval and find the
Okay, that's a good example. So he says so he said in his case, he just says I find the baseline, which is without he's working out to ask questions, when to ask questions, says I the baseline, which is how users behave without the feedback, and then I measure the improvement. So it's experiment based, it's case study based. So when you build something, you have to build a case study. Sometimes you do a case study, like when you do software engineering, knowledge engineering, you build the case study more or less artificially. You just play the same trick as you play in machine learning. You look here, they wrote this paper, they did this case study. Exactly as I was promising, I was discussing, if you do this university, people have done this, we do in this way, we argue it is better. It's just pretty much a lot of hand waving, but we do have some metrics of you say you do better, people using more, so on. The other one, which is the fourth one that you said, is really experiment based. And this to me is very interesting. So, but that again, then how you do? You build a baseline. You have to be this the very complicated way, which by the way, as a group, we are doing a lot. We plan to do a lot, right? We have a baseline. We just study a phenomenon like behaviors of humans, and then we just introduce a piece of software, and then you see how it improves. That's very hard, but it's another one. Again, you're measuring. What you're measuring. You could measure that the better answers, but then you have to know the better answers. You could answer, you can say they answered faster. Is that a good metrics? Yes, it can be argued. Because of course, when you write a paper, since the research about doing something nobody has done, it's not that there is a finite answer, you just to work on it. It's not that people come to you, read the paper, try to argue. So for instance, I was talking to Dacian yesterday, we're writing a paper with him, right? But we are writing a paper, it's actually machine learning, that paper. But what is the point? The point that we came up with a new method, but nobody has done it before. So what do you do? When you've done something new, I had this paper also another problem in the year, some many times, but you're the first one, then you have no baseline. So in this case, as I did many times, the idea was his idea, but it's correct idea. He said, first we run a simple version of the algorithm, then we complicate. So we are our own baseline. Of course, and it's okay. But then you have to argue that nobody has done it before. And of course, if someone finds only one citation where they've done it, then you're rejected, correctly so, right? But then, of course, this is exactly why everybody uses Google data sets. Why? Because once you have a baseline, since it's very hard to build one, you just keep using it. And this is why Google and so on, they are so smart in doing this. Okay? So to conclude, problem, solution, and impact. Problem, what you don't know how to do. Maybe it could be something that you don't know how to do, or something that you know to do very inefficiently. There are many ways of doing it, but it's something that you can argue you cannot do. Then the why question, at least in your mind, it must be very clear why you want to do it. And this also will drive your state of the art. And then the solution, which will come with the evaluation matrix. And as I said, exactly as for the rest, you can do what evaluation metrics you want. There are examples, but in certain cases you have to invent them. Okay? So all of this, I don't know what time is it, finishes my first lecture. So I think it's registered. Then we may want to, what is the next step? The next step is that the people, at least the 3 people I mentioned, and maybe others, I would like to have a presentation for them. I mean, like 20 minutes. And then like, I don't know, 10, 20, 30 minutes, I'll give it a time of where they get asked questions. And we'll nominate a bunch of people interacting with them. And I want to see this kind of interaction. As you see now, that's the way to learn how to do research, okay? And of course, the more people sign up, the better. How we want the slides, at least 3 slides, one entitled problem statement, one entitled solution statement, one entitled the impact. You can choose the order. Usually I do why, what, and how, but this is my way of doing. Some people do what, why, and how. Usually the how goes at the end, up to you. And maybe the minimum 3 slides, maximum, let's say, 10 slides, 12 slides, like a brief introduction. But I don't want to make it too long, because as you find out, writing 10 pages is much easier than writing 1 line of the problem statement. So synthesis is the key part. Okay, these slides should be ready for the reviewers 2 or 3 days before. and then we'll all listen to the presentation. Okay? Fine. So we now set the schedule. We'll have, concerning the timing, I'll think a little bit if you have any suggestions. My idea, maybe you can do 1 a day, I don't know, maybe 2 a day. We need to think how to do it. We don't want to spend, maybe we're going to do at least two a day, I think. Okay, we are done, I think, good. I think we can stop here. Maybe I went too long. Good. Thank you, we should stop. So see you, thanks a lot for everything, and see you in the next lecture.